Alright, so our group is doing human augmentation, whether it is an unfair advantage or if it improves lives. We define human augmentation as any form of mechanical, biological, or chemical alteration of the human body. One mechanical aspect of human augmentation is our exoskeletons, which may have started out as human enhancements. For example, I think I read somewhere the military uses them to help soldiers lift more armaments and stuff. However, the breakthrough was a redistribution of weight that reduced the power requirements by 3 orders of magnitude. Now this extra power was then used to help the exoskeletons move parts of the body by themselves. So exobionics use this extra energy to divert this extra energy to be used as a rehabilitation device to help paraplegics and other incapacitated people walk again. Another form of human augmentation is the skin graft, which consists of allografts or xenografts. A xenograft uses animal skin, usually porcine or bovine, so pig or cow, mixed with other synthetic elements. They are cheap and they are readily available, but they're not very effective. For example, they could prompt a drastic immune response in the patient. Allografts use human skin, either your own or someone else's skin, usually a family member or that of an organ donor. These are better for healing, but they're more expensive and harder to acquire. Also, besides skin grafts, there's actual artificial skin. Some of it serves as a temporary dressing for burn wounds, and others can be permanent, like Integra, which is made of a collagen lower layer and a silicone-based top layer.
So this issue affects many different types of people, and the ones we will be talking today about are people who use them, the hospitals or regulators, surgeons, and society. So while all these stakeholders have many different beliefs and interests, our group as a whole decided that human augmentation should only be used for rehabilitation purposes and not for enhancements.
Okay, so my point is kind of like the opposite of that, actually. My perspective is from that of a plastic surgeon. And so the number of minors receiving plastic surgery is rapidly increasing every year. According to the American Society of Plastic Surgeons, 76,220 teenagers between the ages of 13 and 19 received cosmetic surgical procedures in 2012. These invasive procedures range anywhere from rhinoplasty, which is a nose job, to breast augmentation, and some even received liposuction. A majority of people find this statistic pretty scary, since plastic surgery being performed on adults is still controversial, let alone the idea of it being performed on teenagers. However, others would argue that cosmetic surgery is a gateway to the future, as it is the first way humans have discovered how to majorly reconstruct themselves. Today, plastic surgeons can completely transform a person's face and body to the point that they are no longer recognizable. If this is what surgeons are capable of now, in the future they could be capable of body modification beyond the imagination, such as placing microchips in people's brains at birth or allowing them to instantly communicate with the person of their choice. Plastic surgery and other medical body modification methods represents the future of human development and the potential for improving human life through these surgical improvements. Even non-cosmetic modern medicine has amazing techniques for prolonging life using different implantations and modifications to the body. For example, according to the Heart, Lung, and Blood Institute, a pacemaker, or an electronic device placed inside a person's chest to regulate his or her heart rhythm, can help prevent potentially fatal heart attacks in susceptible patients and allow a patient with a chronic heart condition to live for many more years than they would without one. My best friend, Olivia Johnson, suffered from heart cancer as a baby and was given a 10% chance of survival. However, her surgeon was able to remove the tumor and implant a pacemaker in her chest to make sure her heart continues to beat correctly for the rest of her life. Now she is perfectly healthy and even enjoys riding horses and playing soccer. If scientists are capable of creating a device that helps a person's heart beat and save very sick children like Olivia, the next medical advancement could be something like the creation of a device implanted into the brain of a comatose individual to allow them to begin functioning again. The opposition to such bold medical techniques is that some people, like Christian scientists, argue it is against God's will to interfere with the human body in any way, and all illnesses can be cured through prayer. This is quite an interesting belief, but the majority of people would agree that medicine is far more likely to save a life than meditation. Therefore, if the next step in medicine is to continue inventing ways to improve human life using implanted technology, then everyone should welcome and embrace the benefits of a longer, healthier life made possible by new medicine.
Primum non nocere. This Latin phrase translates to first, do no harm. Although the Hippocratic Oath does not include this exact phrase, the oath does promise to abstain from doing harm. Today, scientists and researchers have been inventing amazing technologies for human augmentation. Some of these technologies include powered exoskeletons, integrated prosthetics, and brain-computer interface devices. All of these technologies have tremendous potential and could drastically change and improve the way we live life. They are also designed to help people overcome any disabilities they may have, born with them or not. And they also have the capability to further and improve humans' abilities. With so much new and innovative technologies being developed every day, the ethics of these devices are being constantly scrutinized. Even though these devices are new and intimidating at first, not using them to their full potentials would be a huge step backwards for scientists. People who would be eligible to use these devices would agree that restricting them would not be beneficial to society, and instead there should be guidelines and criteria that scientists need to adhere to when creating these devices. These devices are able to give people with disabilities a chance to live a normal life. For example, exoskeletons are suits that can make paralyzed people walk again. Brain-computer interface devices also give paralyzed people the ability to move things with their minds. Integrated prosthetics can make people who've lost major limbs be able to have a fully functioning limb again. These devices are designed to give people a normal life again, and some for the very first time. A company called Exobionics has developed a suit that is specifically designed for people with paralysis. Their suit is called the Exo, and it's the middle picture over there. And it allows anyone with paralysis from below the hips to be able to stand up and walk with a normal, full weight-bearing stride. All that is required of the person using it is that they must have minimal forearm strength because of the crutches that are used. In 2013, wounded Special Ops Officer Gary Linfoot was able to use this device for the first time. He was injured on one of his many Army tours and has been paralyzed below the waist and in a wheelchair since 2008. Linfoot was the first veteran to get the Exo suit for personal use. His use of the suit will also provide more information about it in order to further improve it. The suit is currently worth up to $100,000, but Exobionics predicts that the availability of it will increase over time. The company's co-founder, Russ Engels, says that we definitely see opportunity to reduce the cost. When you look back in time, only a few people could afford the first cell phones. Now the masses can enjoy that technology. While devices like this are relatively new, they will soon be able to be distributed and given to people for personal use. The military also has huge interest in exoskeletons because they could give us a huge advantage in wars and combat. These suits could enable soldiers to run faster, carry heavier loads, leap over obstacles in battlefield, and offers protection from bullets and shrapnel. The military has been working on this Iron Man-like suit since the 1960s, but the recent technological advances have finally made this idea attainable. Raytheon, a defense contractor, came out with a powered exoskeleton in 2012 called the XOS2, and these two are pictures of it. This suit is guided by the human brain and can lift up to 3 times more than a normal person. These suits can provide a huge advantage in wars and can put the United States ahead globally in defense technology. If their suits work well in combat, then it's possible that they could be distributed to government officials and anyone else who works in dangerous conditions. Today, majority of the people are most concerned with the morality of human augmentation. With the recent development of nanotechnology, it is very possible that these devices could be planted into people. However, it is hard to draw a line between what is human and what is machine with nanotechnology. Would people treat those who have these devices planted in them differently? Would there be a segregation between people who have them and people who don't? While these questions may seem radical, they should be considered. There's always a negative side to any kind of scientific advancement, and while they shouldn't be ignored, it doesn't mean that research should be stopped altogether. Rather than have an either-or situation, there should be some middle ground with augmentation. Research and development for these devices should definitely continue, but there should still be some parameters and conditions that scientists should adhere to, while also keeping the negative consequences in mind. Human augmentation has so much potential, and the possible negative effects shouldn't stop scientists from developing them.
Since the number of technology and developments that have helped people regain or improve their mobility has increased, it has to be considered how you determine whether or not these people can obtain prosthetics or exoskeletons and what kind of prototype or prosthetic they can use. According to the European Journal of Social Psychology, as far back as 1988, Dr. Paul Kine and Rachel Rosser worked to develop a relationship between the states of illness or disabilities that people had and the stress that the absence or the presence of prosthetic could cause on their loss of mobility. These states of illnesses were developed to range from no disability to slight impairment, all the way to confinement to the hospital or bed, or total loss of mobility and function. Back then, doctors and hospitals found these states and relationships very useful to use, and was even considered to be used as a global indicator for illness and determination of prosthetic use. However, now through the decades that technology has improved and it's become fell into such widespread use, these determinations need to be changed and need to be further considered when developing prosthetics and exoskeletons. According to the Journal of Neuroengineering and Rehabilitation, assistive technology has constantly been improving over the decades, and it is constantly being developed to create a better integration between the patient and the technology. But this majority of this technology is still only limited to the use for disabilities. These technologies are built for people to regain their mobility, not to enhance a normal person's speed and strength to superhuman levels. These technologies are still limited by their power and the weight of the materials that are used for them. Exoskeletons or prosthetics are built to have store an amount of power used for disabled people to be able to regain their mobility to normal levels. They don't contain the amount of power needed for a normal person to do superhuman feats or any sort of recreational activity they wish they could pay for to maintain a prosthetic or an exoskeleton. And once you consider all these factors, you have to consider how can federal regulation control people who use prosthetics for normal day uses, and how the government can regulate people who sell these things. The FDA has certain classifications for medical devices such as prosthetics. In the first class, every medical device falls into low risk to the patients, and they must meet a certain requirement for approval for use and marketing towards people. And many of these prosthetics and medical devices reach these certain guidelines. In the second class, many of these are the same low-risk technologies in the first class. However, in this class, unless a new device or prosthetic is being targeted towards another demographic, or unless the purpose of this technology is different than an already approved FDA device, then it does not require such strict inspection, and it is legal to market it to people and to use it in hospitals. In the higher class, there's a third class, which maintains higher risk technologies for patients. However, many devices do not have to reach this higher class and can fall into the lower class if they apply for pre-market application, meaning that any of the benefits of the technology outweighs the potential risk that could pose to a patient, and it falls into a lower class. There is also the humanitarian device exemption, meaning that if a prosthetic or an exoskeleton is developed to eliminate a disease that only affects less than 4,000 people in the country, then this device does not meet a class 3, falls into a lower class, and does not need very strict inspection. These guidelines and the amount of leniency that can be found within them makes federal regulation of the FDA very hard sometimes in the country, and it also creates problems out of the country. Many devices are clear to market simply because they pose non-critical risk to patients, meaning that many of the risks that could be posed to a patient, if they don't kill the patient, it's very easy for these prosthetics to be marketed to the country. According to the Federal Food, Drug, and Cosmetic Act, single-use prosthetics are allowed countrywide for any hospital to use, but they cannot be refurbished or reused for other patients after their single use with one patient. However, in other countries like Turkey, groups like Walking Peace work to take prosthetics that are no longer in use, refit them, and provide them to other people who cannot afford these higher costs of prosthetics. This may be very beneficial to poor people who cannot afford such high cost medical devices. However, if technology like prosthetics and exoskeletons were to become as common to society as cell phones and iPads are, the recycling of these technologies and the lack of strict regulation for them would prove a great negative effect on society itself and prove obstacles if this technology would need to be integrated further into society general.
So, as it is now, society doesn't really have a problem with human augmenting technologies, except probably chemical augmentation in the form of steroids, because they are mostly used for restorative purposes. For example, cochlear implants restore hearing, and exoskeletons restore mobility. However, once these technologies begin to be used for enhancement to be better than other people, then it creates a gap in equality in society. Assuming inventions of human augmenting are created that can give people superhuman abilities, who would be able to afford them? Unless they are made readily available to everyone, the answer is people with large amounts of money. While a gap in wealth is to be expected in a capitalist society, enhancements would enlarge the gap in power, equality, lifespan, and social class. Human enhancements could arguably create an even greater disparity between the upper and the lower classes. One potential type of augmenting is genetic engineering, or genetic modification. Theoretical physicist Kenneth Ford predicts such an inequality to occur in his essay when he writes, "Major genetic alteration of adults does not seem feasible, and a system of embryonic interventions to manufacture neonates with specific militarily useful genetic alterations would create a pre-specified warrior class, undermining the very idea of a citizen soldier." So another thing to think about is if society believes whether or not altering your body is ethical. Like, most people generally already agree that steroids are not ethical. Another example would be mechanical alteration, like the prosthetics that Oscar Pistorius used in the Olympics. Oscar Pistorius was disqualified from the 2008 Olympics because he apparently had an advantage over people with normal legs. However, he was allowed to run in the 2012 Olympics. But is it ethical for someone to purposefully alter their legs in order to run faster? Or would society say that's cheating? For example, Kenneth Ford also asked if a genetically altered human with, let's say, webbed feet, just to make him swim faster, would be allowed to compete in a swimming competition. We would probably say that's cheating. Also, would the act of changing your body itself be unethical? Which also brings up questions. What's the limit or the line between man and machine?
Human augmentation has been used to help impaired people and normal people worldwide. However, just because it can help everybody doesn't mean it should. While augmentation for cosmetic reasons has been up to people and their own choices for many years, this is a different type of human augmentation. Genetic modification, mechanical parts being applied to your body, replacing limbs with robotic parts, and implanting chips into your brain, these are totally different types of technology besides just cosmetic surgery. Augmentation like this gives people superhuman strength, and it changes the way people are and could change the definition of how you define a human person. These type of technologies should not be used general-wide and should only be allowed to help people rehabilitate themselves and to help everybody who's impaired and to regain mobility in their lives.